Okay, we're going to write down some rules and then practice them all together. So the first one. Thank you, Martha. Okay, so you can just copy that heading down, geometry of straight lines, and then the first rule is saying that angles on a straight line add up to 180 degrees. So I'm going to draw a diagram to show you that as well. But that is the first rule, guys. So just underneath that, you can just draw a straight line and just draw any kind of line just going up from that straight line. It doesn't matter what those angles are, you can draw one line up like that. So if you have that this angle is x and this angle is 50 degrees. Okay, these two angles together, sorry if I'm going too fast, I'll take it slowly. These two angles together are equal to 180 degrees. Okay, so you can just add that there. Just do like a little thing, like a little rainbow. Those two angles together are equal to 180. So that if I know that that small angle is 50, what am I going to do to get the size of angle x, right? 180 minus 50. Okay, it's just like when we did with those triangles, right? If you have multiple angles in a triangle, they all add up to 180. So you're always going to say 180 minus the two that you have. Same thing here. To get x, we're going to say 180 degrees minus 50 degrees. Guys, again, remember with geometry, we always have to have a reason. So the reason for this is angles on a straight line. So again, every time you use this rule, you need to write that in brackets next to your calculation. I'm going to highlight that reason again. So what is 180 degrees minus 50 degrees? 130 degrees. You don't really have to show this calculation, guys. You can just kind of do that in your head if you want to, all right? So you can just think, what is 180 minus 50? It's 130 degrees. So you can just write it, but you do have to have that reason always. Okay, that is very important. Any questions on that? Yes? Yes. Sometimes one, sometimes they just give one mark for the answer, including the reason, but usually. Okay, are there any other questions on this first rule? Okay, the next one. So number 2. Just let me know if someone was busy copying down at the top. I hope not. Okay, the second one is saying that angles around the point add up to 360 degrees. So I'm going to draw a picture for that. It doesn't have to look exactly the same as mine. Yes. And I'll make this one over here equal to x. And this one is 40 degrees, that one is 60 degrees, and this one is, let's call it 170. A little bit to the left. Okay, guys, so the second rule, we did angles on a straight line, right? They add up to 180. Then we have angles around the point, add up to 360 degrees. Yeah, so what we're going to do to get x, it's very similar to what we did up here, where we said the total, right, the full 180 minus that angle. In this case, guys, let's do like a little circle around all of these angles and show that that is equal to 360. Oh, that's a bit thick, sorry. Let's do that. Okay, it doesn't have to be a perfect circle. So all of those angles all together would give you 360 degrees. So to get x, we're going to say the total, right, the 360 minus the other 4. Now, guys, we could actually have used the angles on a straight line to get x here as well. If we just look at that line there, do we see that? Right, so we could have done that, but just because I want to do an example where we're doing angles around the point, let's choose that method. Okay, but in the case for exam, 100% if you do 180 minus 40, get it. Okay, that's perfect. So let's just quickly write here, I'll write on the side, x is equal to 360 degrees minus those three. Now you can do what Ryan suggested, you can add all three of them together and then subtract one value if you want to, that's fine. But I'm just going to do it all in one step. I'm going to say minus 40 degrees, minus 60 degrees, minus 170 degrees. Guys, what do you think the reason for this is going to be? Angles around the point. Yes, or there is actually another option which you might prefer. Just going to move to the side. You can say angles around point. You are allowed to write PT like that for point. Okay, you can abbreviate it like that. You don't have to write out the whole word point. But you can also actually write revolution. That is an acceptable reason angle. So I think you might prefer the shorter one, but maybe angles around the point makes more sense. Remember, either one of those, you'll get them off. Okay, you don't have to write both of them, guys. You're just going to write one of them. Yes. Yeah, you can. You want to. Okay, what's that answer, guys? 360 minus 45, 60 minus 170, yes? Is it 90? Yes. So actually my picture doesn't work. Oops. Okay, anyway, ignore that. All right, so it is 90 degrees. Obviously, it's not on the scale, right? But guys, in the case for exam, you haven't seen a geometry test yet. Okay? Are we sure that it's 90? Yes, okay. We haven't. Yes, I hear you. We haven't seen a geometry test yet, but when you guys get a class paper, we're going to give you a class paper next week. Then you'll see it will say in the heading, diagrams are not going to scale. Okay, so if you're getting an answer like this, where the angle obviously doesn't look like a 90-degree angle, okay, you don't have to stress about that. If your calculations work, then it's fine. Okay, so sorry guys, my picture was not correct. But are we okay with that method? Okay, 360 minus the angle that we have. Okay, let's look at the third and the final rule, and this is also the easiest one, number 3. Yeah, you cool. Yes, you can. Thank you, sir. Okay, the third rule, vertically opposite angles, and I'll explain to you now what that actually means. Vertically opposite angles are equal. Okay, this is a rule that actually doesn't require any calculations. Okay, you'll see now when we do it. I just want to write down what vertically opposite angles actually are. So those are angles that are formed with straight lines intersect. I'll explain out what that word means as well. So it's a lot of new terminology that we're learning today. Okay. Not this time. We'll do it after that. Right, intersect when they cut. Right, the two lines are intersecting, they are cutting through each other. Okay, so you can put that in brackets. The correct mathematical term is intersect, but it basically means cut. All right, so I'm just going to draw a picture so that you can see how this would look. So if we have one straight line and then another straight line that is intersecting the first one, that's cutting through the first one, right? And we have that is x, and this is 46 degrees. Let me just quickly do a calculation here so that my picture actually works this time. And then we have y, and we have 1, 3, 4. So that's vertically opposite angles. All right, so they are opposite each other. So if you want to take a highlighter, you can highlight x and 46. So we see that those two angles are opposite each other. Right, we have two straight lines that have cuts that have met intersection, and the angles that are then opposite each other are equal. So we're going to say that x is equal to 46 degrees. So we don't actually have to do a calculation for that one. That's the easiest one. Okay. So the angle x is just equal to the angle that's opposite x, right? The reason is vert of angles equal. You are allowed to use the equal symbol. That is the reason that we have to use that. Please, vert of angles equal. Every time you use it, you need to write that down. Yes. Okay, I will find with x. And for that, do the same thing for y. Yes. Y and 134 are directly opposite each other. So let's just use a different color. I'll use purple. So y and 134, those angles are opposite each other where the two straight lines have intersected. So y is going to be equal to 134. Same reason, guys, but you do unfortunately have to write it again. Okay, the sooner you get into the habit of writing reasons, the better. So easier it will be to remember when you are in higher grade. Okay. It's very important. Maybe we should just highlight this bit. Vertically opposite angles only will be equal when you have straight lines that are moving. Okay, so I can show you in the picture with me. This is a picture there. Maybe you can draw it as well. Just so that you can see the difference. code is actually in the exercise that you're going to do. Okay, let me just draw one here. If you have something like this, if you have one straight line, and then you have a line going up and a line going down. Are those two straight lines that have been, or that are cut? You have one straight line, right? We can highlight that one. This is definitely a straight line. But this part, that is not a straight line. Okay, so guys, we cannot say, and don't pull this in, but we can't say that this angle is going to be equal to the angle opposite. All right? These do not count as vertically opposite angles because they have not been formed where two straight lines have intersected. Yeah? Yeah? So no vertically opposite angles. Because we do not have two straight lines. Okay, very important, guys. Only if we have two straight lines on the front. Okay, then number 4 is not a rule. We're just going to go over some terminology because sometimes they use a specific term in a textbook, and you might not know what they mean by that. Are there any questions on this, guys? Or on 2 and 1? On these 3 rules that we've written down. Okay. So I'm going to write number 4. It's not actually a rule, it's just terminology, like I said. So for number 4, complementary angles are angles that add up to 90 degrees. Okay, so that's just the terminology thing, guys. If they use the word complementary or complementary angles, then you just need to know that that means that they add up to 90. Okay, so that's the one terminology thing. Yes? Okay, and then the second one is similar but supplementary angles are angles that add up to 180. Now guys, you don't have to use this terminology ever. It's just so that if they give you those words that you know what they mean. Okay, so complementary, add up to 90, supplementary, add up to 180. Okay, that's basically it for geometry. I'm going to give you an exercise now. It's yes. Say again. Oh, we'll see, but I'm going to give you work to do now, and I'm not sure how long it's going to take. I'm going to give you an exercise from the textbook, but then also 2. I mean, they are exercises, but it's literally like 2 questions. Okay, so the textbook, I think you've noticed by now that this textbook is not great. It's just class and a maths one. They don't have a lot of practice. So I have found some extra stuff, which you will find on Classroom. I'll put it on the board as well. Okay, so first you're going to do exercise 10.1 on page 92. And 93, guys. There's another question on page 93. And then on Google Classroom, there are 2 exercises that I'll show you now. Okay, just write that down quickly so that I can put the Google Classroom exercises on the board for you. Or the first one at least. Did you copy that down? All done? So guys, I'm going to put this exercise on the board now, but I want you to do the one from the textbook first. Okay. So if you don't have a textbook here, you'll have to take a picture of someone else, please. So do this first, because this is an easier exercise than the one from the book. Okay. If you start with this one, I'm going to put on the board first, you might feel a bit lost. Okay, so first do the textbook one. Then this is exercise 1, which is on Google Classroom. You place this, two places, and then I'll just show you quickly what exercise 2 looks like. Exercise 2 is a triangle one. Okay, again, just 2 questions. But please, guys, start with the textbook one. Okay. Okay, going on that, guys. You can listen to music if you want to. Maybe we can play some math 24 in the last 5 minutes. We'll see how it goes. I'll be that next. Guys, you don't have to read all the diagrams. Okay. Get going, please.